Yo, yo, yo! This is the next day of leetcode. Yeah, let's get this done. Um, yeah. Okay. So I had to do this last question of intervals again because I just wanted to do this again. So the trick here, as I remember, is to use a priority queue where it stores the size of that interval and the right ending time, and that's about it, right? Yeah, so we basically sort these intervals and sort these queries, and then we process each query and we push these intervals to that queue in the priority queue that we mentioned earlier based on the size of that interval and right thing. When that interval goes out of reach of this query, then we pop it out. Otherwise, we push that result to a map, and at the end we follow the sequence of these queries and return the result. That's all. Okay, let's try this again. So for this, first of all, intervals.size. Bro, I need a new keyboard, man. This is becoming trash day by day. Okay, so first we need n, then we just sort these intervals. Then we sort. Okay, first we need a copy of queries. Right. And then we need a priority queue of a vector of int. I can use a pair also. Priority queue. Okay, now for each queue in queue, and we need an I starting from 0, and we need a map storing the result of each query. So here we check if or while intervals of I of 0 is less than or equals to q, and I is less than n, and then pq dot push r minus l plus 1 and r as a vector. Right. While pq dot top 1 is less than q, pq dot pop. While pq is not empty and otherwise rest of q equals right. Yeah, that's about it really. And then we simply return the answer for q in q queries answer dot push back result of that query. Bro, what is happening? What? Oh, I'm not doing I++ here, which is just sad. Right equals I1, which is right. Left is 0. PQ dot push, the size of that, and the right. Right. If the size is equal, then this. While PQ is non-empty and PQ dot top right is less than Q, then PQ dot pop. Then if PQ is empty, then it is -1. Otherwise it is PQ dot top 0. There is some edge case that I missed. Oh, that's a noob mistake. A very noob mistake. Okay, I'll get a new keyboard, man. Let's explore keyboards. Should I get a bougie one? Reliable keyboard. Long lasting keyboards. Okay, mechanical keyboard with hot swappable switches with swappable USB cord. Then keep a few extra switches handy as well as an additional cord. This will ensure that most of the failure points are okay. I don't know if this keyboard has swappable keys. Okay, it's a rabbit hole for another day. Let's move on to the next one. This is done. So after that, let's do this try question. Given an m by n board of characters and a list of string words, return all words on the board. What? Given a board m by n of characters and a list of string words, return all words on the board. Each word must be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once in a word. Interesting. So, for example, if board is this and the words that are given are these: oath, pee, eat, and rain. Okay, so if I'm at O, yeah, I see that oath can be made. So O has an A, right? So I think at every cell I just have to do DFS. Is that the case? But isn't this just checking like in a hash set or something? How is that different? Let's take a look, man. Copy this example to Excalidraw. Let's say we have a grid like this, and the words given are these. So since this is under try, I mean it's just metagaming, but we have to make a try from these, right? So let's make a try. This is the dummy root node. Then it goes to O. Okay, let me write this properly. This is O. Then P is here. Then E is also here. And then R is here. Right, from dummy node, these 4 nodes appear, right? For oath, we just complete this. Eat. P. Rain. Okay. So, and in the grid, I encounter an O. I check in each direction. Yeah, it is like a DFS. I don't know, bro. Seems a bit sketchy. Okay. So I'm at O, right? Let's say I'm at this position. I see that O exists, and the neighbors I check are E and A. I see E doesn't exist, so I can't move any further, but O exists. So I move here, the position to here. Right. Okay. When I'm at O, I see E doesn't exist, but A exists, so I move here. Then I see A doesn't exist further. O I have already visited. T exists, so I move here. Then I check the neighbors of this. This is already visited. This doesn't exist. This doesn't exist. This exists, so I move here, and I see that this is an end of word. Then I push it to the result. Right. When I push it to the result, do I need to check again further? Yes, because there can be multiple words, right? So okay, then I, F and K don't return anything, it's just empty, so it goes back. Then I start from A here, from the root. Okay. So yeah, it's something, I don't know. Doesn't look like a fast solution. Let's see. Let's see the constraints. Okay, M and N are 12, and words length can be very large. But since M and N are 12, so at max 144 characters can be there. So yeah, but it doesn't even make sense when length is this, right? If words of I dot length, oh sorry, number of words is very large, but words I dot length is just less than 10. Interesting. Mm-hmm. What is this? Try backtracking string. Is it really? Yeah, it seems like a backtrack. Okay, let's look at my past solution. Oh, I haven't solved this earlier. Bro, I just need... Why am I so sleepy all the time? Okay. Come on. Yeah, let me drink some. Okay, when I find a word, I push it to the result, and how... Yeah, I create a try from this, so okay. Yeah, try will be way faster than a simple map. That is for sure. Is it just that? I mean, I don't know. Let's see this guy. Intuitively start from every cell and try to build a word in the dictionary is the powerful way to exhaust every possible ways. Apparently we need to do this in pruning when current character is not in any word. How do we instantly know current character is invalid? Hash map linked list. Okay. Is it just that? Thanks to Diet Pepsi. First I create a try and then do all of that. interview friendly version. Yeah, it's the same thing that I did, kind of similar. Yeah, brother. Okay, I'll be right back. I'll be right back. Okay, I'm back. From a quick nap. Yeah. Okay. So, yeah, let's get this done. So, first of all, we need a try for these words. Let's create that. For try, we just need a node, which will be a struct node. This will contain a list of pointers. The alphabet is just lowercase English, right? So let's do, bro, this key is what? Jackhammer is on again. This might be my last question for the day because I just hate, man. Bro, construction never stops, man. Why? Okay. Bool is EOW. At one place, there is a jackhammer going on. Another place, some drill machine is going. I don't know what is happening, brother. How do I even work here? Bro. Let's get this question done. That's all. I'll just close the stream. Okay. So let's create a constructor for I equals 0, I is less than size, I plus plus. Children of I is equals null pointer is EOW equals false. Now here, what do I need in this? I need a try. That's all I need. I need an insert function, void insert string word, right? Then let's take a crawler. While, or we can do it this way, for character C in word. Harish, brother, hello, how is it going? Okay, for every character in this word, if crawler children C minus A is null pointer. Which problem? Some try problem? Yes. It is 212 word search 2. Okay, I think this search will be in a separate special function, not exactly the search that the try does. So first of all, for each word in words, insert that word, right? Now what do we need? We need some sort of backtracking. So we start from 0 0, right? 0 1 2 3, 0 1 2 3. So we start from 0 0. We check if it doesn't exist. Do we need a visited thing? Yes. Yes, we do. We need a visited also. So let's take out m and n from here. Then let's take a bool visited size m bool n false. Perfect. Insert all dictionary words in a try. Then we just call DFS with board visited. No. In here, right? IJ. And try is already there, so yeah, no worries. I mean, yeah, I can add this try here. So try, which is the root node. That's all. And to keep the result, I'll take a here. Let's do DFS. I'll just copy this definition. This is passed in as reference. This is also passed in as reference. Right. First, we can check if I and j are out of bounds. If I is less than 0 or j is less than 0 or I is greater than equals board dot size or j is greater than equals board 0 dot size, then return. Then we have to check if the ij character exists in the try or not. How do we check that? If root children, the character at ij, which is board ij minus a, is a null pointer, which means it doesn't exist, then return, right? Right. Yeah, I mean it doesn't exist, then return. But if it does, then we have to go there. Then we simply do DFS on all 4 directions. I have to visit this also, so visited of I j will be true. Board visited root children board ij minus a. This seems a long expression. It definitely can be simplified, but I just want the solution, man. I plus 1 j plus 1 I minus 1 j minus 1. At the end, this will be false, so this is the backtracking, right? And how do we check if we encountered an end of word. Do I check just after this? Maybe. If root is end of word, then result dot push back. Oh, I need the word also. Okay. Oh shit. I need that word, man. So maybe I can take another parameter which keeps on building that word. Right? Will that be better, or yeah, I mean I can take a vector of characters, right? Yeah, let's do that. Character, pass it by reference current. Okay, current dot push back board of ij, and at the end current dot pop back. Vector of char to string. Okay, my bad. Oh, sorry. This should be current dot begin, current dot end. Let's see now. Too few arguments. My bad, brother. So after visited, there should be a current, which is just this, 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 and here this is it. What? Calling a private constructor of solution. Why is this in private, man? What is wrong with you, man? Okay, one is accepted, another one. Oh. Oh, okay. So we can put it as. So are there multiple oaths here? Why is it OA? Oath, 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 eat, EAT. Okay. But why is it? Why are there multiples at the first place? That's what I'm trying to see. So I am at O. It exists. OATH. Right. And here there is no other O. Then why is it repeated? Oh, I'm not checking visited. My bad. If visited I j then return. Okay, still wrong. Okay, some multiplications. Visited true. Visited false. If this is visited, then return, right? Then, okay, if I don't do this, are there multiple of these? Yeah. So it does help, but I don't know why is it not. I don't know, this might be a wrong move. Yeah. Okay, I am at 0, 0, current is nothing. Then I see it's not, yep. Okay, I visit this, then I go to the next. I go to all neighbors, then I visit that neighbor. Then if I try to come back here, it won't be allowed. Okay, let's take a look at here what's happening. Okay, so yeah, makes sense. But yeah, I just want to know why there is no other. Oh man. OATH. Where is the DFS happening? So we are doing DFS on this one, right? Yeah, that's fair. But when character C is this, if C is a hash or the next of this is null, then return. Okay, this is just visited thing, right? If then p equals p dot next c minus a. Okay, this makes okay. Words A expected A. What happened here? Okay. Why is it empty? So I create a try, which is just simple A. Then I see it's not visited. Okay. Okay, so this will be no, there is no all of them are out of bounds, so it won't go anywhere, it won't reach this. Interesting. So I need to check beforehand without even going there. Okay, so yeah, I need some modifications here. So instead of doing this boundary check here, I need this here. And yeah, visited can be removed, right? We don't need visited, we'll just change the board itself. If I plus 1 is less than board dot size, then do this. If j plus 1 is less than board 0 dot size, then do this. If I minus 1 is greater than or keyword in C++? Yes, in modern C++ it is there. So if C is a hash sign, or if root children C minus A is null pointer, then return. Otherwise, if root children C minus A is end of word, then push that to result and remove that from the try. What? Sorry about that. This should be C. 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 Okay. Oh, the last character isn't here. Fuck, brother. The last character is missing, man. So in current, oh shit, brother. So I should be pushing back that thing, you know. So current of this, push back board. Do this and then do this. Let's see. Okay, submit this shit. Okay, it works fairly well. So the point was, this recursive function need to be designed properly, otherwise it won't work. We need to check that end of word beforehand without actually moving on to that node. And yeah, there is no need of visited array. We can just change the board to this symbol or any other, and it is good to go. Yeah, it was easy. I mean, it was basic try plus a DFS. Yeah, and this trick is good. Like we remove that, so we don't duplicate stuff. So yeah, it's all right. Okay, so yeah, that was it for today. I know it's just 2 questions, but yeah, it is what it is. Uh, yeah, I'll try to be consistent this week. So yeah, I'll be back tomorrow again, maybe with some more energy to do lead code. Until then, take care. Have a good rest of the day. Bye bye.